So this is the third video of the fuels topic, and this one is on combustion. We've come across the word combustion in the previous videos. It's just another word for burning. And if you're burning something, you are reacting it with oxygen. You need oxygen for fire. If you light something on fire, you are starting a chemical reaction and you're reacting whatever you're burning, you're reacting it with oxygen. And the reason we're going to be talking about combustion and about burning is that we've been looking at fuels. Fuels release energy, but they only release energy when they are combusted, when they are burned. So you need to be looking at these combustion reactions because these are the reactions that take place when you burn a fuel, and that's how it releases energy. So there's two different types of combustion. There's complete combustion and there's incomplete combustion. And the difference, if it's complete combustion, you've got lots of oxygen present, and if it's incomplete, you don't have a lot of oxygen present. When you've got lots of oxygen present and you burn a hydrocarbon, the products are carbon dioxide and water. When you don't have a lot of oxygen present and you burn a hydrocarbon, you form carbon monoxide and water. So you're forming water both times, but when you've got limited oxygen, instead of forming carbon dioxide, so carbon with 2 oxygen, you're only forming carbon monoxide, carbon with 1 oxygen. You've got less oxygen, so you're forming CO instead of CO2. We're going to come back to carbon monoxide in a second because there's a little bit of theory that you need to know about why it is dangerous. But before we do that, we're just going to have a look at some some symbol equations for complete combustion. So we're talking about fuels, and we're talking about crude oil, and you'll be burning different hydrocarbons in order to release energy. So I'm going to give you an example. Let's just say I've got an alkane. That's my hydrocarbon, and my alkane has got 3 carbons in it. If it's an alkane, using the last video, I know that the number of hydrogens is going to be 2n plus 2, so 3 times 2 is 6, plus 2 is 8. So there's my alkane, it's a hydrocarbon, and I'm going to burn my hydrocarbon, which means I'm reacting it with oxygen, and because it's complete combustion, I am forming CO2, and I am forming H2O. Okay, if I had a different hydrocarbon, I will balance that in a second. If I had a different hydrocarbon, let's say I had an alkane with 7 carbons in there instead. Okay, again, it's an alkane, so I am going to double the number and add 2 to work out the number of hydrogens. If this was my alkane and I reacted this with oxygen, because I'm burning it, so I'm reacting with oxygen, I will also form CO2, and I will also form H2O. Again, I haven't balanced these. When I balance these, that's when they're going to look a little bit different. It doesn't have to be an alkane. I could have an alkene either. So I could take an alkene with 5 carbons, let's say. If it's an alkene, then this time the number of hydrogens will just be double the number of carbons. If it's a combustion reaction, I'm reacting my alkene with oxygen, and I'm forming CO2, and I'm forming H2O. So essentially what happens is you split up your hydrocarbon. The carbon from the hydrocarbon reacts with oxygen to form carbon dioxide. The hydrogen from the hydrocarbon reacts with oxygen to form water, and you're forming 2 different products. I have to go back and balance these, and this is something that you can be asked to do. So when you are balancing an equation, you are only going to be using big numbers, and you have to put those big numbers at the front. When you're balancing these, it's always best to start with carbon. Okay, do oxygen last, do carbon first, then do hydrogen, and then do oxygen. So I'm going to balance my carbons. I've got 3 carbons on the left-hand side. I only have 1 carbon on the right-hand side. This is not balanced. When I'm balancing, I can't just stick a little 3. I have to use a big number, and it has to go at the front. So I've got 3 carbons. That means I'm going to be putting a big 3 in front of my CO2, and now I've got 3 carbons on both sides. Next thing I'm going to do is balance my hydrogens. I've got 8 hydrogens here. On this side, I've currently only got 2. If I want 8 and I've only got 2, I will need to multiply by 4. So if I put a big 4, now I've got 4 times 2 is 8, and I've got 8 hydrogens on this side. So that's the carbons done, that's the hydrogens done, but now I need to balance the oxygens. On the left-hand side, I've got 2 oxygens. On the right-hand side, I've got 3 multiplied by 2. All right, I've got 6 oxygens there. 3 2s are 6. And in my water, I've got 4 times 1 is 4. So I have got 6 oxygens. Sorry, that's an O, it's not 60. Oops. I've got 6 oxygens for my CO2. I've got 4 oxygens for my water. So I've got 10 oxygens in total on the right-hand side. I need 10 oxygens in total on the left, which means I'm going to be putting a big 5 because 5 times 2 is 10. So they're the numbers I'm using, 5, 3, and 4 to balance. I'm going to do the same thing with the next equation. I have got 7 carbons on the left-hand side. I need 7 carbons on the right-hand side. I'm just going to put a big number 7. I've got 16 hydrogens on the left-hand side. I've only got 2 on the right-hand side, so I'm going to have to put a big number 8. 8 multiplied by 2 is 16, which matches what I've got on the left. With the oxygens, I've only got 2 on the left. On the right, I've got 7 multiplied by 2, I've got 14 oxygens in my CO2, and I've got 8 times 1 is 8 oxygens from my H2O. So in total, I've got 14 plus 8, I've got 22 oxygens on the right-hand side. I need 22 oxygens on the left, so I'm going to be using the number 11. 11 times 2 is 22. Last one, I've got my alkene this time, but balancing is going to be, I hope it's going to work out the same. 5 carbons on the left, I need 5 carbons on the right. 10 hydrogens on the left, I need 10 on the right, so I'm going to multiply by 5 because 5 times 2 is 10, and that matches what I've got over there. Then I've got 5 times 2, I have got 10 oxygens in my CO2. And 5 times 1, I've got 5 oxygens. Oh, I didn't want this to work out this way. 5 oxygens on the right-hand side. So I've got 10 and 5. I've got 15 oxygens in total on the right. I've only got 2 on the left. So what do I need to put in front of my O2 in order to end up with 15? I need to put 7.5 because 7.5 times 2 is 15. To be fair, they're not going to give you one where you have to use fractions. You can use fractions or decimals if you need to. At GCSE, you're not going to get one where you have to balance using fractions, so don't worry about that. But it's the same process. I've just had to use a fraction. 7.5 times 2 is 15, and that gives me the same number of oxygens on the left and the right. So in terms of these equations, you're not going to be asked to write it out in full. You may just be asked to give the products. If it's complete combustion, it doesn't matter what the hydrocarbon is. If it's complete combustion, it's going to be CO2 and H2O. They could ask you to fill in one of the reactants. If it's combustion, you're reacting with oxygen. Oxygen's diatomic, so it's going to be O2. Or they could give you the full equation and just ask you to go back and balance. Again, when you're balancing, do carbon first, then do hydrogen, and then finally do oxygen. So they're your complete combustion equations. I mean, they could technically give you an incomplete combustion and ask you to write that instead. So if I take my C3H8, and if it was incomplete, and they would tell you in the question, they would say it's incomplete combustion. If it's incomplete instead of complete, instead of forming CO2, I'm going to form CO, and I still form the water. Okay, so basically, if it's incomplete combustion, you're still splitting the carbon and the hydrogen. The carbon does still combine with oxygen, but instead of combining with 2 atoms of oxygen, it only gets 1 because there's less oxygen available in incomplete. The hydrogen will always combine with 2 atoms. Sorry, the hydrogen will always combine with oxygen to form H2O. If this was your equation and you were asked to balance it, I mean, balancing is always going to be the same process. It doesn't matter what the reaction is. I've got 8 carbons on the left. I want 8 carbons on the right, so I put in an 8. 8 hydrogens on the left, I want 8 on the right, so I put in a big 4. 4 times 2 is 8. And then in terms of my oxygens, I've got 8 oxygens here. I've got 4 there, so 8 and 4 is 12 oxygens in total. So I'll need to put a 6 there to give me 12 oxygens. So it doesn't matter if it's complete or incomplete. If you're asked to balance it, you're just going to follow the same process. The other thing you need to know about combustion is theory-based. So incomplete combustion, you said you form carbon monoxide and water. You may have heard of carbon monoxide before. You sometimes see adverts on the TV about it. It is dangerous. It's a toxic gas. So if you're asked about carbon monoxide, don't just say it's dangerous. You need to use that word toxic, or you can use the word poisonous. Okay, and what happens is if carbon monoxide gets into your bloodstream, it stops your red blood cells carrying oxygen around the body, and you can just suffocate internally, which is not particularly nice. So you just need to know that it's a toxic gas, or it's poisonous. It's very difficult to detect because you can't see it, and you can't smell it, and you can't taste it. That's why they have those adverts on TV for a carbon monoxide alarm, because if you have a carbon monoxide leak in your home, you can't see it, smell it, or taste it, and you've no idea you're breathing it in, this poisonous gas, until it is too late. So carbon monoxide is dangerous, therefore incomplete combustion is dangerous. So here's a 6-mark question: the dangers of incomplete combustion. So carbon monoxide and soot, actually you can form soot as well if there's very little oxygen present. Carbon by itself is just soot or coal. So if you've got very little oxygen present, you end up forming some soot. So carbon monoxide and soot are the products of incomplete combustion. Why is that bad? Well, carbon monoxide is toxic. So say toxic or poisonous, don't just say dangerous. It's toxic, reduces the amount of oxygen carried around your body. People can become unconscious and cause death. It's odorless, tasteless, and colourless, so it's very difficult to detect it. And then you've also got soot. Soot can cause lung problems if you're breathing in lots of soot, and it can also blacken buildings, so it's a bit unsightly. Okay, so be aware of the dangers of incomplete combustion. And then underneath here, I've got another 6-mark question. They were asking for the dangers of incomplete combustion, but they just did it in a different way. So it said methane is a fuel burned in a boiler. Why is it important that there's lots of air when you're burning that fuel? So again, when we talked about the differences between complete and incomplete, if you want to make sure incomplete combustion does not occur and you are not producing carbon monoxide, well then you just need to make sure that there's lots and lots of O2. If you've got lots of oxygen, you're going to get complete, you won't get incomplete, and you won't form CO. So that's what this question was asking you. Why is it important that there's lots of air when you're burning a fuel? Well, if air was limited, you could get incomplete combustion. And if you had incomplete combustion, you've got carbon monoxide and soot. Carbon monoxide is toxic, soot, difficult to breathe, all the rest of it. Okay, so just be aware that that's how they can ask those questions. The other thing is when you're burning your hydrocarbon fuels, and we said hydrocarbon fuel, if it's a hydrocarbon, it contains carbon and hydrogen only, but you can have some sulfur impurity. So what I mean by sulfur impurity, so you're going to have your hydrocarbons, so let's just say you've got methane, and you've got lots of CH4 molecules. So these are all hydrocarbons because they have carbon and hydrogen only, but within your methane gas, you might have some sulfur. Okay, it's not bonded onto your hydrocarbon, it's just mixed in with it as an impurity. And if you take your methane gas and you burn it, when you're burning something, you're reacting it with oxygen. So the carbon and your hydrocarbon reacts with oxygen to form carbon dioxide and water, but your sulfur impurity will also react with oxygen, and when it reacts with oxygen, it forms sulfur dioxide. So, if you had sulfur plus oxygen, you're forming sulfur dioxide. Now, I'm not going to be forming water because there's no hydrogen on the left-hand side, so I can't form water on the right-hand side. I've only got sulfur and oxygen on the left, so I'm just forming sulfur dioxide on the right. So when you burn your fuel, if there's sulfur mixed in there as an impurity, it will form sulfur dioxide. Now, why is that a problem? Sulfur dioxide is a gas, okay, but it will dissolve in rainwater to form acids, and that causes acid rain. Okay, so sulfur dioxide dissolves in rainwater, forms acid, causes acid rain. Why is acid rain a problem? It will weather buildings, so it wears buildings away and corrodes metals. It damages crops because it changes the pH of soil, makes it difficult for crops to grow. It kills fish, it kills insects. So acid rain is not going to be a problem to people. It's not going to, land on your skin and burn your skin, but it does affect the environment and it affects buildings. Okay, so if you were asked to just discuss the problems associated with acid rain, just double check the question. If they're asking you for environmental problems, you'll specifically talk about the fish and the insects. If they ask about problems in general, then you're also free to mention buildings. Okay, so the next question here I've got, fuel oil contains sulfur as an impurity. Why does burning this fuel cause problems for the environment? If you burn the fuel, you're going to be releasing sulfur dioxide, dissolves in water, causes acid rain. You're specifically asked about the environment, so I'm going to focus on the crops, the fish, the insects. I'm not going to talk about the buildings. So sulfur and oxygen form sulfur dioxide. You also need to know about nitrogen and oxygen. I mean, you can guess what that's going to form. So you've also got nitrogen, which is diatomic, and oxygen, which is also diatomic, and that can form nitrogen oxides. And nitrogen can combine with oxygen in a number of different ways. You can form nitrogen monoxide, you can form nitrogen dioxide, you can form nitrogen trioxide, depends on just how much oxygen you've got present, but they're all called nitrogen oxides. Now, the nitrogen, you don't find the nitrogen in the fuel. What happens is there's loads of nitrogen in the atmosphere around us. So 78% of the air around us is made up of nitrogen gas, and so in the atmosphere around us, 78% is nitrogen, 21% is oxygen. And the nitrogen and the oxygen in the air around us do not react with each other because nitrogen is very, very unreactive. However, when you've got a combustion reaction taking place inside a car engine, there is a lot of heat. And in a car engine with really high temperatures, you can react nitrogen and oxygen. So they're not going to react normally at room temperature, but in a car engine, you have got high temperatures, and the nitrogen and the oxygen will react to form these nitrogen oxides. So just like sulfur dioxide, your nitrogen oxides can also dissolve in rainwater and cause acid rain, okay? So here, I've written this out for you. You find them both naturally. They don't normally react. High temperatures, they do react and they form nitrogen oxide. So NO, NO2 or NO3. Breathing them in, so it is a toxic gas in itself. Breathing in nitrogen oxides can damage your lungs, but again, as I mentioned, they can also dissolve in rainwater, form acid rain, and acid rain, as I said, has all of these effects on the environment and on buildings. If you wanted to convert your nitrogen oxides back into harmless nitrogen, you would use a catalytic converter, and most car engines have this catalytic converter in there to convert these harmful oxides back into harmless nitrogen. So if we have a look at a few questions, I've actually answered these in the booklet. So just know the difference between complete and incomplete combustion. Know what the products are. So if it's incomplete and you've got limited oxygen, you're going to get carbon monoxide. If it's complete with lots of oxygen, you get carbon dioxide. You're always going to form water. They're both exothermic reactions. Combustion is always going to release energy. Complete combustion releases more energy than incomplete. Oh yeah, this is important. It talks about the Bunsen burner. If you were doing this in a lab and you wanted to make sure that you had complete combustion, if you open the air hole at the bottom of the Bunsen burner, it allows more oxygen in and you get complete combustion instead of incomplete. And then absolutely know the problems associated with incomplete combustion. Okay, it stops your blood cells, your red blood cells specifically, carrying oxygen around your body, and that can cause you to lose consciousness and then death. Also, just make sure that if you are given one of those equations, and you will be given the equation, you'll just be asked to balance it. So have a practice balancing those equations as well.